So I want to give you a couple more examples of solving systems of equations by graphing in case you needed just a little bit more help with that. So here, remember, a systems of equations just means that you have two equations, at least two equations, and you're trying to find what point is true for both of those equations, okay? So where do they intersect? That's what we mean when we're talking about graphing, okay? So in our first example here, we have y equals negative 4x plus 6 and y equals negative 3x plus 4. So remember, our first step is we always want to make sure our equations are in slope-intercept form. And here, both of these are, so we don't need to solve for anything. So when I'm going to graph these, I'm looking first for my y-intercept, which here in my first equation is 6. And I'm going to graph that on the y-axis. So remember, our y-axis is the one that runs straight up and down. Okay. So here, I'm going to plot a point at -6 or at +6. And then I'm looking at the slope. So here, my slope is -4, which is the same thing as -4/1, okay? And remember, slope, we always do rise over run. So because our rise is -4, we're actually going to go down 4. So from 6, we're going to go down 1, 2, 3, 4, and over 1. Okay, and then I'm going to go down 1, 2, 3, 4, over 1 again. And one more time, down 1, 2, 3, 4, over 1. And I'm just going to connect those points as best I can. Okay, so that's my first line. So now for my second line, again, I'm going to start with the y-intercept, which is a +4 here. So I'm going to plot a point at +4. Okay, here my slope is at -3. So that's the same thing as -3/1. And again, we have rise over run. Because our slope, and because -3 is negative, we are going to go down. So we're going to go down 1, 2, 3, and to the right 1. Same thing, down 1, 2, 3, to the right 1. Down 1, 2, 3, and to the right 1. And again, I'm just going to connect those dots as best I can. Okay. And here, I see where those points intersect is right here. So my solution for number 1 is 2, because we went to the right, 1, 2, -2, because we went down, 1, 2. So that is the solution to our first system of equations, okay? For the second systems, again, I'm looking here. We have y equals -2x plus 2, and we have y equals -2x minus 2, okay? So here, if I'm graphing my first equation, I'm looking at my y-intercept first, which is at +2, okay? And then I'm looking at my slope, which is -2, so I'm going down 2 to the right 1, down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. And then I also want to go up a little bit, so I'm going to go up 2 to the left 1, up 2 to the left 1. And again, I'm going to connect those dots as best I can. And now I'm going to do the same thing to my second equation. My y-intercept here is at -2. My slope is still -2, so same thing. I'm going to go down 2 to the right 1, down 2 to the right 1, and then I want some more points on the left-hand side, so I'm going to do the opposite. I'm going to go up 2 to the left 1, up 2 to the left 1, up 2 to the left 1, up 2 to the left 1. Okay, and when I graph that line, I notice that these lines are parallel. They do not ever intersect. So when that happens, don't freak out. You didn't do anything wrong. That just means there is no solution here, okay? Anytime that you see that two graphs have the same slope, you know they're going to be parallel, which means parallel lines are always going to have no solution. So that could save you a little bit of time. If you notice they have the same slope, you don't even have to graph them because you know they're going to have no intersections, no points of intersections. Okay, so here in our next example, this equation is not in y-intercept form, and neither is our second equation. So we're going to have to put those in y-intercept form before we can graph them. So we've got x minus y equals 3. Okay, and then we have 7x minus y equals 3. So I'm going to start with our first equation here, and I just want to get y by itself. So I'm going to subtract x, okay, and we have negative y equals negative x plus 3. And then I notice here that I still have a negative in front of my y, but we cannot just leave it like that, okay? It has to be a positive y. So when you have that negative in front of you, like that, in front of the y like that, that's really like a -1 as a coefficient. So what we're going to do is we're going to divide everything by -1, okay? So that cancels out, and we have y equals, and here, this is really just changing the signs. So if I look and I say, well, what is negative x? This is like a -1x divided by a -1. So those really cancel out, and you're just left with a positive x. And then same thing right here. If I do, what's 3 divided by -1? Well, that's just a -3. So this is what I have to graph now for this equation. So my y-intercept is at -3. And my slope is just 1, so I just literally go up 1 over 1, up 1 over 1. And same thing, down 1, left 1, down 1, left 1. Okay, and I'm going to connect those dots. And now I'm going to solve my second equation. So here again, I just want to move everything that's not the y to the other side. So since it's a positive 7x, we have to subtract it. So I'm left with -y. We cannot combine the -7x and the 3. So we're just going to have -7x plus 3. Again here, this is like if there's a -1 in front of it, so we're just going to divide by -1. And again, what that does is we're going to look at these individually, okay? So if I do -7 divided by -1, that gives me a positive 7x, okay? And if I do 3 divided by -1, that gives me a -3. So I'm going to come here, and I'm going to graph this now. So my y-intercept is at -3. Okay, my slope is a positive 7, so I'll have to go up 1, 2, 3, 4, 5, 6, 7, and over 1. Okay, and so that's a very steep slope, so it might be hard to graph, but we can see where those lines intersect are right here. Be careful how you write this point. Okay, this can be confusing when they're on an x-axis or a y-axis. Remember, we always put our x value first. So my x value here is actually 0. So my answer is going to be 0, -3.